Hello, my name is Catherine Starcher, and this is Lab 1 of Physics 2212. In this lab, we electrically charged two pieces of tape and were able to explore the electric force that they emitted on one another, as well as see the electric fields interact with the gravitational field. The goal of this lab was to calculate the excess charge on two pieces of tape by observing the interaction on the tape with electric fields and gravitational fields at equilibrium. Newton's second law is very important in completing this calculation because the system is at equilibrium and thus has a momentum of zero, meaning that the net force is also equal to zero, as Newton's second law states. Other important ideas are that like charges repel and opposite charges attract, and the relationship between electric field and electric force. Ultimately, I found that the charge of both tapes was positive 1.2 times 10 to the negative 8 coulombs, and that there was an electron deficit. The total number of electrons on one piece of tape was negative 7.59 times 10 to the 10th. A single piece of tape is charged by placing two pieces, one on top of the other, where one is attached to the table or a neutral surface. Then they're quickly pulled apart, and one obtains a positive charge and the other piece of tape has a negative charge. This single piece is observed in interactions with neutral objects, where it is observed that it is attracted to neutral objects, and then it interacts with negatively charged objects, such as a pen that has been rubbed in hair and has been transferred electrons from hair to the pen to give it an overall negative charge. Upon doing this, it was observed that the piece of tape was attracted to the charge of the pen, resulting in a positive charge for this piece. Then two pieces of charged tape are made with opposite charges. One is held above the other, and the bottom piece is raised until it is observed that the top tape is floating above it. This distance is measured, and then using the relationships between forces and fields with this distance, one is able to calculate the excess charge of both tapes. In the first step, we use Newton's second law to equate the gravitational force on the top tape to the electric force on it coming from the bottom tape below it. We use F equals ma to calculate the force of gravity and then set that equal to the Coulomb's law formula and plug in the distance between the two tapes in order to get the charge. This can be divided by the charge of an electron in order to get the total number of electrons, which then allows us to calculate the ratio between electrons and atoms on these pieces. The same result can be found through coding, in which we continually change the value of Q and observe the way that it changes our values for gravitational force and electric force. This can be done until the forces match up, which will then give you the appropriate charge for both pieces of tape. In my case, the tapes were charged positively, and this resulted in a deficit of electrons. In the diagram, the top tape is represented by the blue sphere, with both gravity and the electric force from the bottom tape acting on it, represented by the two blue arrows. The bottom tape is represented by the red sphere, and the green arrow pointing down is representative of the electric force from the top tape on the bottom tape, which is not used in our calculations, as well as the force of gravity, though both are being counteracted by holding the tape. But what if the electrons had positive charge and protons had negative charge? This would have changed my observations because the tapes would have become negatively charged rather than positively charged and would have repelled the negative pen. The second part of the experiment, however, would remain the same in terms of interaction because both tapes would still repel one another. Numerically, the overall charge of the tape would have been roughly the same but with a negative sign rather than a positive sign. It's important to not handle the charged tapes very often because the tapes aren't permanently charged, and each time they come into contact with neutral objects, some of the electrons are transferred from the tape to the neutral object. Thus, it loses some of its charge. In order to have the strongest possible interaction and get the most accurate results, it's important to not handle them often.